Right. So my name is Eric Stevens, and I'm presenting today on sequelize.js. It's a framework that we can use as part of an ORM suite, and it's all based in Node. The actual synthesis of this talk, actually I was talking to Miguel quite a few months ago at one of the after events, and we were talking about SQL and some other things, and Miguel's like, yeah, I don't touch SQL. He's like, that's something I don't deal with. That someone else handles that, and there's a back end somewhere that puts stuff in a database, but I write all the fun front end stuff. So my talk today was to talk more about what happens to that back end and how we could write back end pieces just using Node and frameworks. So that's my lovely family over there, my wife and 3 kids, and some contact information. My Google+, LinkedIn, GitHub. I work at a small web design company, Infinite Web Design. We're based in Lake Orion. It's so small, like about 90% of the company is actually sitting right up front. Yeah. And we build web apps for healthcare and a bunch of other people. So, okay, so getting started, we'll need some prerequisites, just as I mentioned earlier. We're going to need Node.js installed. And it works very coolly with a bunch of different engines. So we have MySQL and MariaDB. Pretty much anything that's a MySQL fork or compatible in language and syntax with MySQL is going to work just fine. We have SQLite. We have Postgre and Microsoft Server, which actually this is one of the few that I found that does actually interface with Microsoft Server. And for the most part, it's drop-in depending on what engine you want to use, which we'll get into in a minute. So our tools right now in my demo, I'm using MySQL Community, Node.js, and Internet Magic, because we're going to be doing a lot of NPM and other magical stuff, which you guys may or may not be familiar with. So we're going to do npm install, save sequelize, npm install, save MySQL, and then we're pretty much done. I'm not going to go into like actually setting up your Node project, init, and any of that jazz, but basically those are the only 2 modules that we need to get started. So this is our basic JS to run Node. And what we're going to do is we're going to do var sequelize, require sequelize. Then we're going to define, this is the database that I've pre-created. It's an out-of-the-box MySQL install, pretty much vanilla. There's not much going on with it. The only thing I've done is I've used the default out-of-the-box root with this very awesome password. And I made a SQLized database. That was pretty much all I did in the actual MySQL command line client. So we're defining that so it knows how to connect. We're telling it what host to connect to and what dialect. So this is the powerful piece that you're able to drop in whatever language. If you have the correct libraries installed into Node, it can drag, like I said, any of the other engines that we talked about earlier without too much reconfiguration. We're going to define a pool of different connections just to help with managing multiple connections at the same time. And this would just run and initializes and connects. So how do we actually do stuff? So with most ORMs, we're going to start by defining some objects. So we have a library in this case. We're going to be making library and book. So we're going to do library. We're going to define title, description, and address. As well, we're going to define a book with title, description, and a published date. The other nice thing, as I said before, about abstracting out the database piece is that we're using sequelize dot for the types. You don't have to know that the sequelize strings of varchar 255. We don't have to know the exact syntax of a date time in that particular language. Like if you're dealing with something from like Microsoft SQL to MySQL, you'd have to realize, oh, well, the database object that comes back, like the SQL string that comes back, has slightly different formatting on a date. You don't have to iterate through any of those changes if you're changing your back end. And then we define one relationship here. Library has many book. Again, up to this point, compiling this doesn't do anything. Like if we run this in Node, it doesn't do anything. The actual magic is the sequelize.sync function. What sequelize.sync does is, in this case, we're doing force true, which is the nuclear option of syncing. Force true will nuke your entire database of every table that exists and create the database exactly as you just described it. So if we ran this, it would, if we had, it doesn't care if you have a libraries table or you have a books table or anything else. It's going to wipe that clean and basically start again fresh with what we just defined. So obviously, if you're just testing or just fiddling around, the force true is nice. But in the other case, you're going to be really sad. So you have to be careful running that. Dropping all your tables, kind of bad. But the cool thing, like I said, is we didn't have to write anything SQL-wise to actually make any of this magic happen. As you see on the right-hand side, like your relationships and your different tables, because these are kind of underlying your tables, can get really complicated really fast. So why sequelize.sync? So using that, instead of doing all of this SQL, which drop table if exists, books, create table if not exists, like this statement is pretty common when you're writing like modular tests to go and drop a table and recreate it and make sure everything's working correctly. So instead of having to write, I don't know however many lines that is, more than likely we're also going to have some sort of relationship, or we're going to have those things defined somewhere else in our JavaScript already. So why not leverage the things we've already defined and let it write the SQL for us? So that's a quick way to get around having to memorize like all the date times and how to write the constraints and foreign keys. By defining our relationships and by defining our objects, it's going to write all those things for us. A lot of the original ones, a lot of the demos and a lot of the tutorials have you writing a just giant one monolithic index.js, which works perfectly fine. But obviously doesn't scale very well. Eventually we're going to have tons of different models, relationships, and all these different things. So instead, I've refactored the original code, which is a lot more clean as far as the actual code base goes. Again, we're actually taking the sequelize init out. We're putting it into a new models directory. So I've created a new model subdirectory and put a new index.js in there. And that's going to actually handle our connection piece. So our parent project, our parent index.js, doesn't even need to know the connection information anymore. So instead what we're going to do is we're going to loop through all of the existing model.js files that we have in the models folder. And for each one of those, there's a little syntactical magic going on to loop through each one, split off the name of each file that we have that's not index.js. And then we're going to go ahead and initialize it. The only thing that gets tricky is when we have to do our associations. Because we're handling each model in isolation. It doesn't necessarily know, the library doesn't know that book exists and book doesn't know that library exists. So we have to have that be able to be shared. And so we're actually going to use a class method within sequelize to be able to invoke those. And we're going to pass around the different models to each other so that they know that they exist. So an example over here. So we've taken the previous method, which looked something like this, which was very kind of compact, but again, not very modular. And instead, we've converted it to something like this. And this block does the exact same thing that we've done before. The only thing is now our association is actually contained within our model file. So instead of having them kind of scattered wherever we want in our index.js, we can contain it very easily within here. So what is that doing for us? It's hopefully making it a lot easier to maintain. And if you were managing a lot of models, you could easily just drag a new model into your models folder, recompile, and you're good to go. All right, so this is how we get data in and data out. Obviously, we want to be able to get things in and out. So this is our now new index.js file. As you can see, we don't even need sequelize. We're going to inherit or grab the sequelize out of our models index.js, which we're going to require. Down below that, we're going to do our sequelize sync force true, just like I said, just to drop all our tables to get a clean slate every time we run. Then we're going to do var book equals models.book, so that instantiates a new book for us. Then we can do book.create. You can actually create, there's getters and setters on the book that are created automatically by our definition. So instead, you could use the setters manually and then do book.save, or you can do it all in one line by doing book.create. So in this case, we're passing in the title and the description and executing that. If you turn on the debugger in Node, it'll output the SQL that's being executed. So we can tell that it's executing insert into books. As another thing, it's pluralized aware. So we made book. There's nowhere that we really said books. But when it creates the tables for us, it knows that one instance is a book, so create the books table. You can turn it off. And one of the other things that's very, very flexible about this framework is a ton of the conventions that it uses can be overridden. If you don't want it to pluralize your tables, you want it to match exactly the name of your object, you can turn on that just by adding a definition in your object definition. You can have it so that a bunch of the other settings, like the things that it declares, down here we can tell it has updated at and created at. Sorry, it's down at the bottom there. Updated at and created at, we never defined those. They're defined out of the box and they're kept track of as we do methods to change or update the values. It'll keep track of those. So we don't have to constantly be doing like a now variable where we're pulling time dates out of our server or anything else. It's going to handle keeping track of those timestamps for us. If we wanted to change the name of those or totally get rid of them, again, in the declaration for our object, we can override any of those things. But here we see it's creating it and then doing the insert into our table. So that's a really easy data in method. So our data out method. In this case, there's a lot of different search functionality and some other stuff wrapped around how we get objects back out. In this case, we're going to do find one. Underneath the hood, the find one does a limit one or top one, again, depending on the language that you're dealing with. It just pulls out the first one, kind of like pulling the first one out of the hat. We're going to chain .then and then do console.log book title. That's just going to spit out our book title. So pretty easy. We're just pushing something in the database, pulling it back out, puts it into an object for us, has a bunch of getters and setters predefined that define all of our different properties for us. And then we could just do book.title and it'll output our title for us. Yeah. Yes, it's all promises based, yes. So the you can chain, later on we'll get like a kind of deep into the then chains. But yeah, these are returning promises. So book.findOne, and there's different searches, because in the back end it's writing the SQL, executing it, and then when it comes back. You can also handle like exceptions if there aren't any, and different things like out of there. So we talked earlier about our associations, where I said the library has many books. It's really in depth in that it can handle, just like any other ORM, it can handle one-to-one, one-to-many, many-to-many, any of the type of relationship databases that you need. It also dynamically creates bridge or link tables for you. So if you say book has many libraries and many has library books, it will create the link table in between to solve your many-to-many problem, and it'll maintain that link table for you, which is nice. Especially when you're doing something like an insert, where you're having to chain things, where in a normal database structure, you might have to do your insert on one side, do your insert on the other, take the keys, and then do your insert on the middle table. So it'll handle all those inserts for you. So here we're going to do library.create. We're going to pass in name and address. We're going to chain that into, we're actually going to pass that newly created library object into the next function and do book.create. So down there, we can actually still access the library.id. So this would be creating the relationship as well as doing a chained insert. You wouldn't have to necessarily do this. Normally, you wouldn't be creating a library and a book at the same time, but it's just that you can pass along that newly created library to whatever functions follow and access any of the methods, or in this case, auto-inserted IDs as you go. Now we can do book.findOne. The new thing that we're doing in the find one is we're doing include library. So by default, when you get that object, it does not do any of the joins. So it's not going to go out and find any of the other related data. You'll still get your keys back, because those are columns in the table that you're in. But it's not going to go out and connect to something else. It's actually going to just return the key. But doing it this way, you're telling Sequelize, I need the data that's in library as well. And behind the scenes, it's going to construct your joins for you. So it's created the IDs by our definition, and so it knows how the tables are related, and it knows how to write the joins to join those two tables together. So we can do book.title and library.name. Yeah? Yes, there is. Yes, you don't have to chain them this way to do that. Also, if you happen to, depending on how you're writing it, a lot of these examples were actually written more so that you could run this in a single index.js and just have it execute and run. Typically, you would be dealing, which we're going to get to near the end, with actually having some sort of like interactive framework that's like accepting these calls, where you wouldn't have chains like this. you would have normally like more single, like Ajax, object being passed back and forth. So, but so this is just more like an example of an index you could actually run and compile in Node and have it see output on the screen. So not necessarily real world examples, but just something, a way to show the association. So next we're going to talk a little bit about validation. So we talked first about defining our models, defining how all those different objects relate together, having SQLize build all our tables for us without having to write anything, doing inserts, updates, and deletes without writing any SQL, and then obviously how do we get data back out. If you wanted to, you can also include validation. The validation has a ton of different methods. These are baked in, and the ability to write whatever custom validation you want. So there are pros and cons to doing this in what's considered like more the middle or back end versus the front end. But you could have this returning feedback back to your users. Like if you had it passing back some sort of a JSON object back to our front end that can give you this type of detailed feedback into what happened. The nice thing about this is that it's going to stop your inserts from actually going into the database. So even if your front end, for whatever reason, has something that validation was missed, it could be a second layer of validation to not let insert happen if these things are not true. So in this case, is email true? We added a new contact email to our library. We just data types.string. We did validate is email true. So if we do library.create, we're going to push in contact email as ASDL. So that's obviously not valid. So when we do that create, we actually can catch the error that's thrown out, and then have some sort of error handling baked in that returns the error to the user, or whatever in our stack at that point, whatever we want it to do. We may just want to just swallow it and just not do anything if we got some bad Ajax data or JSON for whatever reason. So here we're going to output, and it says validation error, validation is email failed. So it's a nice, very quick way in the definition of the object that you're defining to say, these are the fields we want to validate that need to be numeric, need to be greater than this, less than this, or any of the other stuff. So again, it could be a second level to make sure we're not getting junk into the database. Before we talked about that the methods themselves have getters and setters defined for them. So the getters and setters, we can actually define our own or override the existing ones to do whatever it is that we wanted to do. In this case, we're going to do two quick getters and setters just to expand out some of the things. I found, at least in messing around with this, that the getter methods were really helpful, especially when we have certain blocks of text that we're getting often. A very typical one is like first name, last name. We want that concatenated into like full name or full name and title, or like this address block, where we're always going to pretty much want the whole address block like in a nice string format, where if we were writing the SQL, we could do a concat or do other things to like paste all that together into a nice column name. But here we can actually write a getter method to do that for us. So we just define full address as a function. We have return this address plus space plus the city, comma, state, zip. So when we run that, what we're actually going to do is down here, we can do book.find1. Then we can output library.fulladdress. So that getter and setter will actually be executed. In this case, the getter will be executed in that line of code. The only gotcha that I found in doing it this way is when you do this.address, is it's actually going to invoke the getters for these individual properties. So if you have something chained together, or you've overridden the get method for like this.address, you're going to be actually invoking, it chains the invokes for all of these as getters. Yeah. Yes. It actually makes this as a property. If I were to dump out like at the end of this, if I were to dump out at that moment, I added that full address, by the way, to a library, to the library object. If I were to dump out the library object, like after I created one or after I got one out of the database, that is actually going to exist as a property. So that get property will be, or that property will be set to whatever the result of that is. Similarly, on the opposite side, we can have setter methods. And the setter methods also chain back out. In this case, we're going to have it do a split by a pipe to set the title and description for our book. So if we had some way to get the data in that was passing in like that pipe or those two fields separated by a pipe, sure, in our logic in the back end, we could split those manually or have some other logic in between. But if we're consistently doing that, just code to that versus coding to doing some splits. So here we can just do the split there, take those two pieces. You probably, if you were actually doing this, you'd want to check to make sure, do we get two arguments, things like that. But in this case, we're going to just split it, and then we're going to assign the title and description right off the bat. So down below, we have book.create, and this time we're setting our title disk property directly with our pipe. And down below, we're doing our library.full address. And this is our output. Both of them run. So that's our output is exactly what we'd expect. So you don't have to actually, and you can expand that to any of the different properties. You can mix and match. You can chain them together.
So quick question. When
Yeah.
you're passing the getters and setter methods, you're passing that into some sequelize.
You're doing that in your object definition.
Right. The sequelize. So sequelize eventually gets that signature and will convert those internally to getters and setters.
Yes.
That's why you don't have to read things as functions.
Yes.
It will automatically internally convert that into properties.
Yes. Yes, correct. So it just saves a lot of time in code duplication. So like I said, the most common one I've seen is like first name, last name, which gets duplicated over and over again. And address blocks usually are for the getters. Yeah. Yes. Mm-hmm. Yes. If you passed into when you chained off the then, if you passed into the next function in the chain, book, the object book, then that object would be available down below. The book you just created would be available. Yeah. In our case, no, because we let it be null. If you wanted to, yes, yes. You could, you can enforce referential integrity that you can't insert, like if the ID is null, like if you're not doing an insert, like if the foreign key doesn't exist. In our case, we've let it anytime you want. All the columns are set to be nullable, so the joins will work fine. Also, I've noticed that when it writes the joins, like down here again, when we're including the library piece, remember I said before it does the joins to create those. You can override how it does the joins, but by default, it always does outer joins, which are always going to get you the results even if you don't have the keys. So if I would have forced it not to, then obviously if there's no relationship, a straight join is going to drop our book without the representative library attached to it. Also, when you do deletes and updates, depending on how your underlying schema is defined, specifically your deletes you can set to chain. So if I delete a parent, right, that's going to break my referential integrity. I can't really do that. I'll leave a bunch of orphans, right? And so you can have it set to go kill all the orphans first. Then you can kill the parents. So we don't want to leave any parents without any children, and we don't want any children without any parents. So and you can chain it to do that. So if I say I have a book exists in a library has a bunch of different books. If I'm removing the library, it'll go and remove all the books for me if you want it to do that. Or you can let them just be orphaned and their records will just be set to null. The referential key will be set to null for all of those, assuming that it's allowed to be null. So all the examples up to this point were very meant to be run in a single index.js, or in our case, we split out our models to make it a little bit more manageable to manage a bunch of models. But all the then chains and stuff like that, where you're asking like, oh, why did you do it that way? It was meant just so we could get some data in there and just show some examples of how things work. Realistically, where we wanted to get, the end result is the magical, as Miguel says, the RESTful API that I just shove stuff into and just magic in the database happens. So in this case, we're going to tack on a couple more things just to turn our sequelize.js library into more of a RESTful actual API that we could build a front end on. So we're going to install Express and Epilogue. Epilogue is a framework that helps wrap all of sequelize.js, all the getters and setters, a bunch of the search functionality is all wrapped inside Epilogue. There's also Sequelize, I believe it was Sequelize, I forget now off the top of my head, Sequelize-rest or REST-sequelize, but it looks like whoever was maintaining that hasn't updated it in a long time, and there's a bunch of scalability issues with it. So far, Epilogue looks like it has a pretty good following behind it, and it's being maintained. A lot of the pull requests are going through. So anyway, so it's pretty easy to set up. And again, most of the work was on the Sequelize side. So we're looking at, I don't know, a handful of lines to turn our Sequelize into a nice RESTful API. So we're just going to initialize Epilogue, define our app, which is Express, our Sequelize object, which is a Sequelize. And now we have to define what is equivalent to like our routes, basically. So if we're dealing with MVC type, you have our routes, and those are you could be populating those directly. SQLite does have the ability for you to manually create routes for every one of your objects and wrap it in Express or some of the other quick front ends. But this app, using Epilogue, makes it a lot nicer to be able to wrap all that stuff up. So we just define our library resource as epilogue.resource. We pass in our model of library, which we defined. Our endpoints, that's going to be our getters. And in this case, we're defining a custom search. By default, the searches, like for the URL-based searches for the Epilogue framework, are very grabby. They'll search every column. So the end resulting SQL, let's say we had 4 or 5 different columns, will be like, where this column is like this, or this column is like this, or this column is like this, or this column, for every single column that you have. So a lot of times you'll probably want to be writing either specific gets that search on a specific field, or in this case, we can define our own search parameters. And in this case, we're going to define param search names, and our attribute we're going to search as names. So, all right, let's look at how that looks. All right. So we're going to bring this over. Yeah, it is. Back over here. Increase the font. Anyway, so what we're going to do is we're going to, let's see. That did not help. Okay. Well, either way, we're just running Node. So I'll just run Node. All it's going to do is initialize our connection and just tell us that we're running on port 3000. That's pretty much it. The red text is because I hard errored earlier when I was testing it. The hard error was because I wasn't running MySQL in the background. So if you're not running MySQL, it'll hard error, can't connect to the database. So obviously you could put catches around that piece, but I did. So it's basically telling us, yeah, we're connected and the API is listening. So the easiest one to do is going to be, here we're just going to do /books. So we're connecting to our local host and pulling out books, and we get a nice object back. So we didn't have, again, at no point during this have we written any SQL to connect to any of this stuff. So we can pull up, in this case, books or book 1, and it's going to pull up our book and return a nice JSON. Now I'm just dumping the JSON on the screen, but typically you'd have something feeding off of this to do your very cool, Angular, whatever shenanigans that you want on the front end. Yeah. Yes, it does. It parameterizes all the inputs on inserts and updates. And again, you can also define, if you have specific fields that you want it handled differently, you can always override the getters and setters if you really wanted to make sure. I mean, it does parameterize them, but if you wanted to clean out like HTML or something, you could set on there to do like a regex to pull out HTML or do whatever you wanted before you actually push it back into the database. We can, again, we looked at the, so we can do stuff like this, where we're going to do search names. That was the one we defined. So we can do, and get back our data. Yeah? Yes, you can. I'm not going to. But yes, you can. It does, for all the methods, it does create all the input and output to do that. Yes. But like I said, the nice thing about it is that when we get all this stuff in, all the routes, all the get, set routes, all that, all the creation and what it returns are all set up for us without having to hand code all those. Some of the other SQLized stuff has you building all those yourself. So basically they just made that wrapper to make it a lot easier to take, okay, I have this great SQLized thing, I've defined all my objects. How do I push that? How do I interact with it, right? Besides hand coding index.js or app.js. Also, we talked earlier in our talk, when I was talking about some other people, they asked, is there migrations integrated for database changes? It does have migration support, so you can do both, upgrade, downgrade support, and you can execute that through the SQLized library. As far as production-wise, I know of a few, from what I was reading online, a few people are using SQLized.js in production. I'm not. Also, you can, before we talked about the force option, obviously, which is the nuclear option of nuking everything. If you were taking this framework and adapting it to a database or schemas that obviously you already had all your data in, doing that force would make you sad. But you can actually define all the fields. Let's say in your field, by default, SQLized creates created at as the name in that particular object. You can override that. Like in our table, we call it like add date, or date add, or whatever it is you have, and you can override all those. And when you do your .sync, it's going to go check to make sure, okay, are all these fields that you created, all these columns mashing up to what's in the database? So as long as all the schemas match, yeah.
You do the complete reverse. So far you described being totally code-driven, where you do data structure data code. You completely reverse that. Whatever structure the database is, use that.
I don't think so. That's a good question. I don't know. I know as far as I looked at, like as far as adapting it to an existing thing, I was having to create the objects and define the properties based on the tables and relationships as they exist. Even more so if you have relationships that are not defined by an actual FK, then the magic won't work, right? So if you have an informal relationship without, in the database itself, an FK linking those two tables, it's going to have no way to know how that works, right? Also, I found that in the very beginning, we defined one database to connect to. It does support passing in an array of databases, and then we just have to dot notation like the particular connection that we want to use, because it'll create two different connection objects, one to each database. It does not support cross-database foreign key relations very well, but within the same database, it works very well for all the different iterations of key relationships that you might need. Something else? No? Yes. If you chain it through the then keyword and the first part fails because it's returning promises, it will abort the rest of the then chain. No. I think, well, I shouldn't say that necessarily. It depends on when we initially set up our connection pool. There's different options in the connection pool for the transaction isolation. And I believe you can set it to be very pessimistic in that, so that a single, as long as you're handling it in your calls so that both of them are chained together, then it will roll back the entire transaction, assuming that the database supports that rollback. Yeah. I believe it does, but you have to set that up in your connection object before you do that. Now, if you're doing it that you're doing two separate posts, obviously it sees those as two discrete methods, and so it won't. It depends on how your front end is feeding in your data. But if you had it creating like a complicated object, I think you can have it chained together and do one shot to do it, instead of having it to do two. That's pretty much all I had. Does anyone have any other questions, comments? That's fine, go ahead. No? No one else? Okay, go ahead.
Okay. The feedback conversion, does it know how to do that snake case to camel case? That will be classic.
Yes, you can change it to be snake case or camel case. You can change whether it inputs underscores or not underscores.
Like I want my variables in JavaScript to be camel case. My database, they use snake case.
It depends on if your database is case sensitive or not.
Snake case, like, depends on
Yes.
So, but I want my fields to be camel case.
You can define a map that defines the property.
It's not automatic.
Well, what I'm saying is that you could define the property to be different than the underlying database column name. So if you wanted it to be called blah, but in your actual table that column is called Steve, you can set it so that when you get the object it says blah, but underlying when it actually does the mapping, that's called Steve in the table. So but by default, when you create, if you use it to drive your schema, if you're using SQLize to create all your tables for you, there's tons of different options to define like how you want it to do the naming. So you can change it to snake case, camel case, whatever you wanted it to be, and it'll create the underlying table for you. So if you have a table that already has different casing, then you would have to manually override those. So it'd be kind of tedious to override all of those, but you could. Because a lot of this is driven, like I said, it's much faster to do this if you have some new project that you're working on that you want to just get something up and running without writing like hundreds of lines of SQL over and over again, especially having the ability to do the sync force. So if you're rapid prototyping and you're just throwing something together, every time that you run that sync force, it's going to nuke everything that you had. Or if you're doing some sort of testing where you're inserting a bunch of different stuff and you want to start with a clean slate every time, instead of having to run a SQL script, and keep that maintained, instead you just keep your objects maintained and you can run your sync to start over again. It does assume that. And you showed up and you're like, Ruby, yay, and then it's like JavaScript, and you're like, no. I know.
Yeah, so like it was interesting that the active record, like kind of describing the table and then using that's actually more of an active record thing. And I think SQL is more of to describe the schema
Yes,
in JavaScript.
it creates the schema.
And then manages.
Yes, correct. Like I said, it's really nice if you wanted to be like, okay, I have a bunch of things that I'm going to be modeling anyway in JavaScript, so why don't I just let it build my tables for me? If you wanted to hammer this on top of some existing database that you already had, and you wanted to use that type of mapping to do things, the other thing is, like I said, it's relational aware, like it knows all your different joins, all the different tables, it handles all the inserts, chaining, deletes, all the other stuff that would be code that you'd have to write over and over again. Like every insert for every one of your tables could be hundreds of lines long, depending on how many columns you have. This is going to manage all that for you. You're just going to define, this is my table, these are the fields I have. I'm going to set these properties, save back to the database, write my SQL for me. Yeah. Yes. Yes. So if you wanted to take something that already existed and like port it over to be using this to manage your stuff, you could still do that fairly easily without having to completely nuke everything and start over again. Just be careful not to do force. But yeah, you can easily do that. And then, like I said, the nice thing is that once you've done that, then you can pass off like the management of your schema and delete how many untold lines of SQL from your backend, which Miguel wouldn't care because he doesn't have backend anyway.
One of the things it seems like with this kind of approach, you can maximize a lot of flexibility in the client and server. So it seems like a strategy. It's about splitting the code for visibility. But is there any hooks or libraries or anything that SQLize can do for hooking local storage or anything like that? Would be great.
No, I have not. Like I said, it has a bunch of different, like, it supports a lot of different languages, but I don't know about local storage.
Because that would be really cool if you use the same models on the server browser verified and use it on the client side and then have some local storage bridge.
Yeah, that keeps them.
That would be sick.
So, like I said, the sequelize is relatively new, as far as like getting a lot of support for a lot of different things, and they've been extending it with like some of the other things I've talked about earlier were relatively new changes that they've added. So, it's getting better and better. Just like I said, the epilogue framework, the previous example that I had, even a couple months ago, was using a completely different framework to make a nice RESTful API. So instead, I ripped it all out and changed it to epilogue, just because it was like the one other example I had was quite lengthy as far as lines of code. This one is like 10 to like wrap our existing models in a nice, Express API layer. So.
How would you compare this to Next?
I think I don't know. I think each one has its own pieces. There's a couple of nice things that I like about this. Just that from spending a little while messing around with it, some of the conventions that it uses I prefer is kind of nice, and I like as much flexibility as this has to override pretty much everything, like from the database creation to the other nice thing that I liked was the support for Microsoft SQL, because there's a huge install base of Microsoft SQL, and most of the other tools I looked at, nothing has Microsoft SQL support. So the ability to actually plug in and talk to a Microsoft Server SQL database was kind of cool, I thought.
I think I may have missed this earlier. Is there a way to flag columns in?
Yes, you can. When you create one, when I created my original definition, which I can go back to here. Also, I have the code. You have to be very ashamed at my very, very horrible Git repository that I did very quickly upload this like earlier today. I have a functioning demo in there with a bunch of commented code out. The functioning demo runs the REST layer, like we talked about earlier with our two models that we add. And then there's a commented block in the just generic index.js to add stuff to your database. So if you want to uncomment that out and run that, it'll nuke your tables and recreate that data that we had.
I like your UI.
Yeah, do you like that? It's a good UI. See, because every other talk we go to has a beautiful, beautiful front end, and then the back end is just hand waved. Oh, I set this. I hand coded all this JSON. It'll come from somewhere. I know it will. But look at all the cool stuff we can do with the JSON that we get. Look, we can push stuff. Where does it go? I don't know. Somewhere. Database. I don't know. So.
Sounds like you were talking.
So, like I said, another thing that, like I said, it's going to be unfortunately horrible to read, is it does pull out, like I left the debugger on, so as I was doing stuff, you can see the SQL statements kind of trail by as it's going and collecting things. So we asked earlier about like the ID, like do we have to define an ID? If we defined a book, it knows books, and we define libraries, so it knows libraries, and it's created the IDs for us. It's created the ID columns for you. So if you had some other, it's setting them to auto number in MySQL or sequence or whatever. So it'll keep track of all that for you without you having to define each individual one. So some of the columns come like pre-built in. Obviously ID, the update, and the create are baked into every model. So you don't have to add those over and over again because most of them are going to have it anyway. But you can customize them however you want. If you wanted to call it, my custom ID, it's more than happy to do that. So, anything else?
Well, it's connecting to the database. I'm assuming it's using some library or something in between.
Yes.
What is it using?
We installed, at the very beginning, the two modules we installed were obviously Sequelize and the MySQL library, like the Node module to do that. So it's assuming that the underlying associated Node module is in there. There's other options too that you have to set, like if you're talking to a different database. There's other parameters in our connection object that you have to set. But the easiest one out of the box is the MySQL ones, and I think Postgre is pretty easy too. But But yeah, that's pretty much it. So that's Sequelize. All right.